we're asked to choose the graph of z is greater than 1.3. So z is referring to the standard normal distribution. And the standard normal distribution is centered at z equals 0. So at z equals 0, that's where you could like fold this bell-shaped curve in half with a piece of paper and it'd be the same shape on both sides. So z equals 1.3, we follow the conventions of numbers on number lines. To the right means we're getting bigger. So here's z equals 0, z equals 1.3. That looks to be the right spot. And then look, there's two options that have z equals 1.3 in the right spot, a little bit to the right of 0. This is the correct option because this is where z is greater than 1.3. To be greater than something means to be to the right of something in the number line in mathematics. Okay, we're asked to find the percentage. There's many different ways of doing this. There's a table in the appendix of the textbook, and in all statistics textbooks they have a standard normal distribution table where you can look up z equals 1.3, find out the corresponding percentage. If you want, I can help you figure out how to do that. I use web resources, so here's a good one if you want to pause the video and write this down. If you go to this website, this lets you type in a z-score and convert it to a percentage. So the z-score for this problem was 1.3, and it's one-sided, right? Because a two-sided interval would have two shaded areas. This is one-sided, just a right tail. So I'm going to click one-sided, hit submit. And then I want to use this one over here, the right tail, the 9.68. 2 decimal places, so 9.68% is what I got. And you can get that from a table. You can get that from StatCrunch. I think StatCrunch is a z-score calculator. Z is less than 1. So remember, z equals 0 is right here in the center of all these. So that would be -1. That should be -1, not +1. That's written incorrectly. Z equals 1 is here. That's good. Z equals 1 is there. And the one we want between these two options is this one, because that's less than. That's the area to the left of z equals 1. And then a percent, I'll use that same website. Z equals 1. To the left, that's 84.13%. You get the same thing if you were to look this up in the table in the appendix of the textbook. Okay, z-score between two things. So -0.5 should be a little bit to the left of 0. 0.9 should be a little bit to the right. So it looks good with all these. And look, see how z is sandwiched between these two? That means we want the area between -0.5 and 0.9. Okay, so to find out the correct graph, z is between these two, so that means you're looking for the area between those two values. And then to find a percent area, so you can still use this website, but what you'll want to do is look up z equals -1. Actually, no, the two side won't work. Okay, type in -0.5. And look, this is going to give us the percent of the area to the left of -0.5 or to the right. I'll just write this down real quick and I'll show you the trick. And then the other z-score we had was 0.9. So if you submit, that's the area to the left. We don't want the area all the way to the left. We don't want all that tail. We want just this area between the two, right? So to get that, what you'll do is you'll take the bigger area and subtract it by the smaller area. So the percentage we're looking for is found by calculating 81.594 subtracted by 30.8537. So 81.594 subtracted by 30.8537. That's 50.74 to the second decimal place. 50.74. Okay, this next one, z, the absolute value of z is greater than 1.6. So if you solve that equation, that inequality, what was it, 1.6? Yeah. And there's two solutions, okay? Z could be less than -1.6, and z could be greater than 1.6. I don't know if you remember that from algebra or not, but that comes from the fact that, look, if you were to plug in -2 in here, the absolute value of -2 would be +2, and +2 is greater than -1.6, right? So that's why this inequality is there. So you want a two-side limit. Oh, sorry, I'm starting to use calculus speak. You want a two-tailed z-score and negative 1.6 and positive 1.6. You want the area to the left of 1.6 and between. So if it's symmetric like this, where it's the same area, what you could do is you could just look up the z-score for negative 1.6 and then double it. Because it's a symmetrical distribution, you'll have the same area over here. So let's do that. Let's look up negative 1.6. The area to the left, the area of that left tail is 5.47, and then the right tail was going to have the same area. So let's just double that. We got 10.96 when we round to the second decimal place. Oops, we want this one. And it is 10.96 if I remember correctly.